Hi, my name is Victoria Craig. I'm a fifth-year student studying psychology, and I'm making this video to explore Chapter 3 of Dr. V.S. Ramachandran's book, Phantoms in the Brain. Chapter 3 is about phantom limb syndrome. This is the third video in a series of videos exploring Chapter 3, and my job is to explain the origin of pain that some patients with phantom limb syndrome experience. So 1/3 of patients suffering from phantom limb syndrome experience a painful, immovable phantom. Many had pre-existing pathology in the nerves resulting from actual paralysis or timely blunt trauma, while people born without arms have fully functioning phantoms, typically. I will begin by explaining the origin of the phantom limb sensation in the brain, which occurs due to a feedback loop from the brain to the muscles and back. When you decide to wave goodbye, for example, the action begins in the supplementary cortex of the motor cortex, situated in between the frontal lobes and parietal lobes. It sends specific instructions about the sequence of events that must occur to execute this behavior via nerve impulses which travel down the spinal cord to the muscles on the opposite side of the body, and then waving occurs. At the same time, copies of the command signal are sent to the processing areas, the cerebellum, and, most importantly for our purposes, the parietal lobe, informing them of intended action. This launches a feedback loop, during which the supplementary motor area sends a command for the action to be done, and the muscles send a message to the cerebellum and the parietal lobe, confirming that in fact you have waved your hand. Modifications are made as needed to lead to smoothly coordinated movements. This is how basic actions are carried out, a feedback loop from the brain to the muscles and back. We are simultaneously able to perform the action and comprehend the action. A similar series of events occurs in patients with phantom limbs. When one decides to move her phantom arm, the brain sends the command even when the arm is not there. The action is still monitored by the parietal lobe, which confirms that an action has in fact occurred, even though it has not. Through additional research, I've learned that this continual association of command and lack of movement is called Hebbian learning, which is a deeply established relationship between neurons resulting from repeated and persistent stimulation. As it is said, cells that fire together wire together. So the brain has learned that the limb is paralyzed through association. This phenomenon is called learned paralysis in patients who experience a painful phantom limb. While the arm is still part of the body, but due to an accident has been paralyzed, the feedback loop from brain to muscles and back continues as usual, but the parietal lobe receives repeated information that the limb is not moving through visual signals. Because the patient can see that the limb is not moving, the brain is receiving visual signals that the arm is immobile, even as commands to move are sent. The brain learns thus that the arm is paralyzed. Now that we understand the origin of the pain, we can search for a cure. Dr. Ramachandran hypothesized that if a patient could receive visual stimuli confirming movement of the arm, pain and perhaps even the phantom would eventually disappear through a process of unlearning or disassociation. He created the mirror box for that reason. See the next video for Chapter 3 of Ramachandran's Phantoms in the Brain on Phantom Limb Syndrome for an explanation of the mirror box and its amazing capacity to alleviate pain in phantom limb sufferers, and sometimes even remove the phantom.